limited number of visitors are now allowed back into Yellowstone National Park.
When we think about volcanoes, one of the first things that comes to mind is an eruption. These volcanoes cause a rift in the Earth's crust, allowing hot lava gases and volcanic ash to escape from beneath the surface. While an eruption is probable in the presence of a volcano, it is clearly evident that volcanoes are one of the most destructive forces on the planet. There are currently more than 1,500 active volcanoes across the globe, but only about 15 of them are considered to be supervolcanoes. While the number of supervolcanoes is far lower, the eruptions they generate are extremely volatile, with a magnitude of 8 on the Volcanic Explosivity Index, with 8 being the highest number on the scale. The Yellowstone caldera, located in Yellowstone National Park in the western United States, is one of these supervolcanoes. Just recently, officials from Yellowstone National Park issued an announcement on a disastrous event that is going to take place in the near future. So what's going on at Yellowstone Park? Do we need to be concerned about the inevitable catastrophe? Join us in today's video as we explain why park officials are concerned that Yellowstone will crack the earth open. With about 4 million tourists every year, it is no surprise that Yellowstone is widely regarded. The park is known for its wildlife and many geothermal features, attracting a large number of visitors each year, and even prompting those who have previously visited to return just to witness the park's mystical features over and over again, making it one of the most famous tourist destinations in the world. Yellowstone's presence was first recognized at least 11,000 years ago when Native Americans began fishing and hunting in the area. Scientists discovered this knowledge while investigating ancient deposits near the shore of Yellowstone Lake. Yellowstone National Park, on the other hand, is not your typical park with luscious green grass and gorgeous stone park chairs. In fact, the opposite is true. Yellowstone National Park was established in 1872 and is often regarded as the world's first national park. The supervolcano hiding beneath the ground has been closely and continually researched since 1923. But magma activity has recently led the ground to swell and rise by up to 25 centimeters, or about 10 inches. The rise leveled off, indicating that the magma was cooling and hardening. This was an early indication to scientists who have been monitoring the sleeping monster's behavior that it may be ready to awaken. Most of Earth's history from the formation of the Earth 4.6 billion years ago to approximately 541 million years ago is known as the Precambrian time. Rocks of this age are found in northern Yellowstone and in the hearts of the nearby Teton, Beartooth, Wind River and Gros Ventre mountain ranges. During the Precambrian and succeeding Paleozoic and Mesozoic eras, 541 to 66 million years ago, the western United States was covered by oceans, sand dunes, tidal flats, and enormous plains. The Rocky Mountains were developed through processes of mountain formation that began at the end of the Mesozoic and continued into the early Cenozoic. During the Cenozoic era, roughly the last 66 million years of Earth's history, massive mountain building, volcanism, faulting, and glacier molded the Yellowstone area. The Absaroka Range, which runs along the park's north and east edges, was produced around 50 million years ago by a series of volcanic eruptions. However, this episode of volcanism has nothing to do with the current Yellowstone volcano. Around 30 million years ago, enormous swathes of today's west began to spread apart along an east-west axis. Around 70 million years ago, this continual stretching process accelerated, resulting in the present basin and range topography that characterizes much of the West, including the Yellowstone area. An intense episode of volcanism began around 16.5 million years ago, around the borders of present-day Nevada, Oregon, and Idaho. Subsequent volcanic explosions can be seen all the way from southern Idaho to Yellowstone. This 500-mile trail of over 100 calderas was formed as the North American plate migrated southwest over a shallow source of magma. The migration of the North American plate moved the Yellowstone area closer to the shallow magma body about 2.1 million years ago. This volcanism remains a driving force in Yellowstone today. In the greater Yellowstone area, magma, molten rock from beneath the Earth's crust, is near to the surface. This shallow body of magma is caused by heat convection in the mantle. Magma plumes ascend into the mantle, melting crustal rocks and forming magma reservoirs of partially molten, partially solid rock. Mantle plumes transfer heat from deep within the mantle to the crust, resulting in hotspot volcanism. As tectonic plates move over hot regions, they leave a path of volcanic activity. The hotspot that now lies beneath the broader Yellowstone area left a swathe of volcanic deposits over Idaho's Snake River Plain when the North American plate migrated westward during the last 16.5 million years. Pressure from the shallow magma body has built two resurgent domes inside the Yellowstone caldera after the last of three caldera-forming eruptions. Magma could be as close as 3 to 8 miles beneath Sour Creek Dome and as far as 8 to 12 miles beneath Mallard Lake Dome, and both domes inflate and collapse as the volume of magma or hydrothermal fluids beneath them fluctuates. The entire caldera floor rises and falls, but not as much as the two domes. Net inflation has shifted the caldera floor to the south over the last century. As a result, Yellowstone Lake's southern sides have sunk and trees now stand in water, while the lake's northern end has risen to form a sandy beach near Fishing Bridge. In historic times, remarkable ground displacement has been reported along the central axis of the caldera between Old Faithful and White Lake in Pelican Valley. Surveys of suspected ground deformation began in 1975 with vertical motion surveys of ground benchmarks. By 1985, studies had revealed remarkable uplift of the entire caldera of more than a metre, 3 feet. Later, GPS readings revealed that the caldera experienced subsidence, sinking until 2005, when it rebounded to a severe uplift episode. The greatest vertical movement was observed at the White Lake GPS station, located within the caldera's eastern rim, where the total uplift from 2004 to 2010 was around 27 centimeters, or 10.6 inches. While Yellowstone is a spectacular sight, some troubling aspects are emerging. Scientists noticed a significant and sudden uplift last year, and this is a clear indication that a global catastrophe is on its way. While the sleeping giant stirs from time to time, this uplift is unprecedented in scientific history. As scientists and the entire country realized this, another realization began to emerge. If this volcano erupted, no one knew what to expect. This volcano has begun to rise at the fastest rate ever recorded in the last decade. Speculation that the volcano will only erupt in the next 100,000 years is fading, and experts who previously thought Yellowstone was a dormant volcano are rethinking. Everyone has begun to prepare for the possibility of this volcano suddenly erupting. One can only imagine the devastation if this volcano erupts. But as a result of the recent uplift, will the volcano erupt? Yellowstone officials discovered a massive chunk of magma that began pulsing last year, and experts are unsure if smaller volcanic occurrences, such as hydrothermal bursts or lava flows, are reasonable to expect. The underlying activity has reached a level that has fueled speculation about when and how powerful the volcano will erupt. The frequency of earthquakes in the Yellowstone region has increased in recent years. Yellowstone experiences between 1,000 and 3,000 earthquakes per year. Some of these quakes are minor tremors that go unnoticed. Scientists can use some of the most advanced earthquake detection and monitoring equipment to quantify the level of activity in the magma pool below. A reservoir can be found barely beneath the surface and rather close to the ground in Yellowstone National Park, which is home to a subsurface magma lake. This reservoir is known as the magma chamber. The tremors, whether felt or not, inform scientists how quickly the magma chamber is filling up. The increasing strength and frequency of earthquakes across the park may indicate that a new batch of magma is being injected into the magma chamber. It's difficult to say what these quakes mean for Yellowstone National Park. Nobody knows what Yellowstone will do next. Aside from the conclusions that can be drawn from researching the Yellowstone volcano's distant destructive past, not much else can be said. Because of how long ago the eruptions occurred, data from previous Yellowstone supervolcano volcanic eruptions cannot be relied on to accurately predict what the volcano will do next. According to a Yellowstone National Park system alert, the massive dome-shaped uplift is constantly growing in size. This is undeniable evidence of increased volcanic activity beneath the ground of Yellowstone National Park. Yellowstone officials have been forced to close the park as the volcanic uplift continues, making it inaccessible to visitors and even certain researchers. This mini lockdown was implemented to protect people in the event of a volcanic eruption, which appears to be closer now than it has been in the last 600,000 years. If a full-fledged volcanic eruption occurs, Yellowstone National Park authorities and the federal government may have to do much more than close the park to adequately protect the human population. Whole cities must be evacuated to protect human lives and property from volcanic eruptions like the one that occurred 600,000 years ago. While such a large-scale evacuation has never occurred before, in the event of a volcanic disaster, residents in neighbouring towns and even states may be forced to relocate far from the park. However, there is no guarantee that this will work. A major volcanic explosion the size of Yellowstone will be so deadly that few, if any, states on the American continent will be spared. So what can be done in the event that Yellowstone erupts? Supervolcanoes have the ability to erupt at thousands of times the regular rate. It was thought that an external trigger such as an earthquake was needed to bring about a giant blast. However, investigations at the European Synchrotron radiation facility in Grenoble reveal that the sheer volume of liquid magma is sufficient to trigger a catastrophic supereruption. The last Yellowstone eruption, over 600,000 years ago, blasted so much ash and numerous gases into the atmosphere that it most certainly had a considerable impact on global weather. It also most certainly resulted in the extinction of an entire species, particularly those found exclusively in North America. Worldwide civilizations are likely to be wiped out as a result of the direct and indirect consequences of an eruption, as well as the immensity of the Yellowstone supervolcano. The entire world will be devastated, and surviving civilizations must recover from the long-term effects of volcanic eruptions, ash, and toxic compounds released into the atmosphere. Except for evacuating the entire continent, there isn't much that can be done to reduce the devastating impacts of a Yellowstone outburst. Let us know what you think about Yellowstone supervolcano in the comments section below.